Welcome back, dear students. Today we'll continue with the same exercise 7A on indices. So again, I assume by now you are familiar with laws of exponents. Okay, so with that assumption, let's begin. Okay, so the first question for the day, I'm taking 7 sub number 2. So you need to simplify this. Okay, so look at every step very carefully. Okay, now what you need to do here is, see, first let's see the numbers which can be factorized. For example, this 27 can be factorized into 3 into 3 into 3. Okay, 9 also can be factorized. It can be written as 3 into 3, isn't it? 3 into 3 is 9. So this 3 cannot be factorized, so it's kept as it is. This 8 can be factorized and it is written 2 into 2 into 2. 5 cannot be factorized, 27 can be factorized, and this is again 3 into 3 into 3. Okay, now see here carefully. So 3 is kept as it is. 3 into 3 into 3 is 3 cube, isn't it? Okay, to the power n plus 1. Okay, plus 3 into 3 is 3 square into, this is kept as it is. Similarly, 2 into 2 into 2 is 2 cube into, this is this much, minus 5, and this 3 into 3 into 3 is 3 to the power 3 and whole to the power n is there. Okay, now if you look at this, okay, and this, you need to multiply the powers, isn't it? And in this case, you have 3 squared into 3 to the power 3n minus 1. So in such cases, you need to add the powers. Okay, mark my words, I need to multiply the powers in these two cases, and here the powers will get added. And what about this? We cannot do anything with this because here we have base is 2 and here the base is 3. For applying the laws, base has to be same, isn't it? So if both are same, then only we can apply the laws of exponent, but here since they are not same, that's why we cannot apply. So that's why, see here, we multiply the powers. So 3 into n is 3n, 3 into 1 is 3. Okay, now similarly, as I said, you need to add the powers. So 3n minus 1 plus 2 is how much? It is 3n plus 1. Okay, because minus 1 plus 2 gives you plus 1. Okay, and here similarly this, okay, this can be written as this, isn't it? Yes. Why am I doing this? You will understand later. So this is written in this way because ultimately if I multiply the powers, I'll get 3n only, isn't it? Okay, so that's why this is written in this way here. Okay, now if you see here carefully, here the power of 3 is 1, and that's why again here the powers will get added because the base are same, isn't it? So this is 3 and this is also 3. So we will add the powers. So we have 3n plus 3 and here it is 1. So that's why 3n plus 3 plus 1 plus this is 3n plus 1 only. Okay, so this is kept as it is and denominator is also not changed. Okay, now if you see here carefully, 3n plus 3 plus 1 is 4. So that's why this is 3n plus 4. This is kept as it is and the denominator is also kept as it is. Now in the next step, what am I doing is, this plus 4 is there, isn't it? So I am separating it. Okay, so if you separate it, you have to write 3 to the power n into 3 to the power 4 because ultimately when you add the powers, you will get 3n plus 4 again. Okay, so this part is written in this way. Similarly, the next part is written in this way. I have separated power 1. Okay, denominator is as it is. Now if you see in the numerator, what is common? You see that 3 to the power 3n is common. This is also there, this is also there, so it is kept common. In the denominator, this part is common, right? So this is kept common. Now all of you know that 3 to the power 3 whole to the power n is 3 to the power 3n. So these two now gets cancelled. Okay, now here, see here carefully, you might be wondering from where do we get this 8? See, whenever you take out this part outside, you get 2 cube and 2 cube is 8, and here you have minus 5, isn't it? So you have minus 5 out here. Okay, now 8 minus 5 is 3, isn't it? So these two gets cancelled. So 3 to the power 4 is how much? 3 into 3 into 3 into 3, that is 81. Okay, plus 3 to the power 1 is 3 only, divided by what is left here, 3, because this and this gets cancelled, so only 3 is left in the denominator. So this is 81, 3 into 3 into 3 into 3 is 81, plus we have 3 divided by 3, and how much is this? This is 84 by 3, and when you do the cancellation, your answer turns out to be 28. Okay, so you may pause the video and note down the solution. Let's have a look at this. Look at the given things carefully. Okay, so question says if a is this much, that is x to the power m plus n into y to the power l, this is l. Okay, b is given to be x to the power n plus l into y to the power m, and c is equals to x to the power l plus m into y to the power n. So you need to prove this. Okay, so let's take the left hand side. So this is my left hand side, isn't it? Now let me substitute the value of a. What is a? A is this much, but a has the power m minus n. Please be careful with that. Okay, so this is my n, a. Okay, so this is my a, and the power for a is m minus n, isn't it? Now next is b. Okay, so b to the power n minus l. B is this much, so that's why this is my b. Yes, and the power is n minus l, isn't it? Similarly for c, the power is l minus m. So instead of c, I am going to write this, and you see the power is l minus m. Okay, now see, for this and for this, I am going to put this power separately. So basically the powers will get multiplied, isn't it? So m plus n into m minus n for x. Okay, into for y it will be l into m minus n. Okay, into for x, again in this case l, n plus l into n minus l will be the power. Yes, and for y it will be m into n minus l. Similarly the same happens with the last case as well. Now what am I going to do is I am going to keep all the x together. Okay, so for x it is m plus n into m minus n is m square minus n square. Okay, now here we have the power of x is n plus l into n minus l, that is n square minus l square. Okay, and similarly here you have l plus m into l minus m, which is l square minus m square. Now since you have got same base, that is x, x, and here also x, the powers will get added. Okay, and the same happens with y also. Okay, so for example lm minus ln. Okay, here mn minus ml. Okay, here it is nl minus nm. Okay, so here you see that ln, nl or ln or nl both means the same, so that's why they'll get cancelled. Similarly mn and nm gets cancelled, and ml and lm gets cancelled. Here also n square, l square, m square gets cancelled. So here we see that it is x to the power 0, and this is y to the power 0. Anything to the power 0 is 1. Yes, so that's why your answer turns out to be, this is also 1, this is also 1, so that's why 1 into 1 is 1. So that's what we need to prove, isn't it? So you may pause the video and note down the solution. Okay, let's have a look at this particular question. Now for this, you need to make use of one very important formula which you have learnt in your class 8. Okay, so the formula for a cube plus b cube and a cube minus b cube. Okay, so this is given to us, isn't it? So you know when it goes up, this minus b becomes plus b. So that's what is done here. Same thing is done here as well, and this is also done in the same way. Now you know that since there is a extra power from outside, you need to apply power law, that is we need to multiply the powers. So when you multiply a plus b into a square minus ab plus b square, how much is that? That is equals to always a cube plus b cube. So that is the formula for a cube plus b cube. Okay, a cube plus b cube is a plus b into a square minus ab plus b square, and similarly the same happens with the rest. So you get b cube plus c cube plus a cube. Now suppose if there is a minus b and here you have a square plus ab plus b square, then it becomes a minus b into a square plus ab plus b square. And how much is that? That will be equals to, remember, a cube minus b cube. Okay, now in this case you see base is x for all, so that's why the powers will get added. Okay, so I have added all the powers, and here you see that how many a cube are there? A cube are there 2 times. Here also we have got a cube, here also we have got a cube. Similarly, b cube is also 2 times, c cube is also 2 times. So basically, if you take out 2 common, you get a cube plus b cube plus c cube. So this will be the simplified version of this particular expression. So pause the video and note down the solution. So your homework is on the screen. So you will complete all the undone problems from exercise 7a. See, if you have understood whatever we have done till now, then you will definitely be able to solve them. Okay, so with this we close. Thank you very much.